Hey guys, this is Chapter 8, Section 4, Part 2 video. Notice the direction says evaluate. Evaluate always implies that you are trying to come up with an answer as in just a number, like not a variable, not a crazy exponent, not a square root, a cube root, just a regular old number for an answer. So the really good news is we can do these on our calculator. Now, I'm not going to lie to you. You could literally, depending on which calculator you have, type in all these problems, hit enter, and it would give you the answer. So I got to see at least a little bit of work. And here's the work I'm expecting to see. The point of the section is to be able to change fraction exponents into roots. So if you watch the first video, this is actually relatively easy. You put the bottom number here, scribble that guy out if you want because we're done with them or used them up, and then just write the other stuff in here. Okay, exponent of 1, would I need it? Nah, I wouldn't need to bother if I didn't want to. Doesn't hurt either. Okay, so you've showed me some work. You've shown me your ability to change from one form to another. So now, yeah, you could pick up a calculator, type in the square root of 289, cross your fingers, and hope it comes out even. And in this case, it does. It's 17. Now, if it didn't come out even, we could do a factor tree. But evaluate implies that you're going to get an answer that's just a regular old number. No square roots, no fraction exponents, nothing funky. All right, so for number 2, here's what I would expect to see. A root, bottom number goes for the root. Everything else goes on the inside. Okay, now depending on how much you want to try to do with the calculator, let me show you how you could proceed from this guy in parts. So normally in math, there's a procedure, right? Like PEMDAS has to be done in a certain order or you're going to get the problem wrong. Here's the one time in math that you get to do it in either order. So what I mean is you could take 243, raise it to the third power first, and then take the fifth root, or you could take the fifth root of 243 first and then cube it. So the question would be, which would be easier? Well, what would happen if you took 243 and raised it to the third power? Would it be a big number? Yeah, it'd be a huge number. So it would be easier to take the fifth root first. So again, calculator, and you picked up a calculator and typed in the fifth root of 243, it would tell you 3. So that kind of implies that I've done this, and I've done this, but I never used that exponent that was inside yet. Now that's a little bit easier, kind of a small item to take care of. Again, calculator if necessary. 3 cubed is 27. That guy's done. All right, number 3, negative exponents. Do you remember? What did I do? Understood to be on top to start with. Negative exponents means move them. I moved him to the bottom, but what happened to the negative exponent? He is now positive. So I do need to see that as part of your work. Also, here's the point of the section. Change it into a root. Denominator is the root. Everything else goes on the inside. So I could do 27 to the fifth power first. I think you're crazy if you do because that'd be a huge number. So I'm going to do the third root. I'm going to take care of that guy first. Third root of 27 is 3. I have yet to do the fifth power. Again, I could pick up a calculator, and it's going to tell me that. So put some thought into that, right? Original problem had a negative exponent. Final answer was a fraction. Well, that's the point, right? Negative exponents may move them to the bottom, and that would make perfect sense that 243 ends up down on the bottom. Now, speaking of the order in which you do things. So yeah, you get a break once you've changed it into a root, but that doesn't mean that you get to violate any of these other math rules. So PEMDAS, what comes first? Because we have a division going on here, and we obviously have an exponent. So it would be really tempting in that problem to do 8 divided by 2 is 4. But look where the D is, and look where the E is. So I got to do that exponent that's on top first. And if I'm going to do a fraction exponent, I change it. Bottom number. The rest goes inside. I'll get to the 2 eventually. What's cubed root of 8? It's 2. I haven't done the fourth power yet. I'll get to that 2 on the bottom eventually. So again, it'd be tempting to cross those twos off, guys, but can't do the division part until I do the exponent. 2 to the fourth is 16. And finally, I can go ahead and divide by 2. All right, so a little bit tricky, but the point, again, is change it to a root, then pick up a calculator and do it. All right, we're going to do a few of these simplify expression problems down here at the bottom. I'm not going to have time to do them all. So here's some more good news. As long as you remember the rules for exponents, which we did way back in chapter 2, you get to pick up a calculator and do them. So I see a multiplication problem. The rule for exponents was to add. Do you have a calculator that would add 2/5 and 2/5 for you? I believe you do. I'd like to think that you would have known that 2/5 and 2/5 makes 4/5. So I just added them up literally. Now, I will accept two different answers. Nowhere in the directions does it say you have to give your answer in fraction exponent form. So I could put root number, this guy inside, but that would be one more step to do and one more thing to remember. So if I were you, I would quit right there. Either answer is acceptable. All right, next problem. There's a negative exponent, but hopefully you remember one of the quirks with negative exponents was I'm not allowed to move negative exponents out of parentheses. So I'm just going to apply the rule. So what was the rule for exponents when you had one inside and one outside? It was to multiply them. Can you read that? Because I can't. Doing my best here, guys. All right, so I'm going to multiply. Could you use a calculator for this? Yeah. So I'm going to give you unreduced version. Multiply the top, multiply the bottom. Does 18 over 6 reduce? Yeah, it does. Down to -3. So the only thing that you have to remember mathematically, the only thing that's not going to help you out so much with the aid of a calculator, is the fact that negative exponents are supposed to go to the bottom. So I moved them down to the bottom, and now I'm done. All right, number 3 is a division problem. The rule for exponents, doing a division problem, was to subtract. Well, again, you could use a calculator, but I'd like to think you would know 7/10 minus 3/10 is 4/10. The reason the calculator would help you out is it would have given you the fraction in reduced form. So if you're going to do it the way I'm doing it, you better remember we always want to go simplest form as possible. So reduce that guy down, j to the 2/5. Done. Okay, I'm going to squeeze in 4 and 6. I'm going to save 5 for the next video because it's similar to some of the stuff down there on the bottom. All right, a little more complicated with 4, negative exponent. This time I have no parentheses, so I could move it if I wanted to. That guy's a positive exponent, he stays. The guy on the bottom was a negative exponent, he moves. Do you remember why I didn't move the 2? 2 is understood to be to the 1 power. That's a positive 1. He's not supposed to go anywhere. If there were parentheses around that 2x, then yeah, the whole thing would go. Here's a times problem. Hey, what's the rule for exponents when multiplying? All you have to do is add them. Would a calculator do that for you? It sure would. So if I add the fraction 4/5 with the fraction 1/3, it comes out to 17/15. Now, even though 17/15 is kind of crazy fraction, nowhere does it say that we can't have a fraction on the top. We can't have a fraction exponent for an answer. So I'm done with that guy, as long as he doesn't reduce, and 17 over 15 does not reduce. All right, I'm going to catch this one down the end here. Now, this might scare you because of all the negatives, but we could do the move it or leave it thing. But since the rule for exponents here, I see, you know what? I stand corrected. I was thinking something different on that one. So I'm going to save 6 for the next video, and I'm going to go ahead and do 5. So this is a little bit weird. On 5, I got a negative exponent, which means he's got to move to the bottom. So life would be good if you were allowed to quit here. But here's why you're not allowed to quit. If a fraction exponent means the same thing as a root, I'm not allowed to have a root on the bottom. So I got to multiply this guy by something to make the fraction go away. Well, think in terms of a pizza. If I had 1 out of 3 slices and I gave you 2 more slices, I'd have a whole pizza. So 1 times y to the 2/3 on the top would be y to the 2/3. And the 2 guys on the bottom, if you add the exponents, would be 3/3. But what's 3/3? It's y to the 1. Where did the fraction exponent go? Well, he's gone off the bottom, and nobody seems to care what happens on the top. Pardon my lousy looking fractions there, guys. Tune in for video